slip of your reciprocating pump. What is the slip? It is defined as the difference between your theoretical discharge and actual discharge. Okay, the difference between your theoretical discharge and actual discharge. So when you are drawing the water, if you draw the section, okay, this is the pump, okay, this is the suction side, and this is your delivery side. When you are drawing this water, okay, due to this cylinder, okay, discharge is the formula is the ALN by 60. So this is your theoretical discharge. Okay, but what will happen in the real condition? This discharge will be little lesser than the actual discharge. Okay, so theoretical discharge. Okay, so in this condition, the always whatever we act will get in actuality it will always less than the theoretical discharge. Maybe some other reasons, due to friction, due to pressure will vacuum will not create, okay, or due to any leakage, everything may be chances. So in this condition, the actual discharge will get always lesser than the theoretical. So that difference is called your slip. So difference between the actual and your theoretical. Okay, so that is the called your slip. Okay, or disparity between your predicted and actual discharge is called your slip. So this slip, as I told you, the actual discharge of the pump is always lesser than the theoretical discharge. This is the case. To get the actual discharge, okay, in real condition, we will multiply with some coefficient that is called CD with respect to the theoretical discharge. Okay. Now we can say that the slip is the difference between theoretical minus actual. Okay, to get the actual discharge, we multiply with your CD. So can I write the CD in this way? The CD is the actual ratio of the actual by theoretical. Okay, but we will always represent this slip in percentage. How much percentage of the water is not getting, or what is the losses? So we can always represent in the percentage. So that if you write this equation, the slip percentage, or simply that is your Q theoretical. This is 100%. Okay, in a theoretical, but we'll get lesser, okay, than the theoretical. So we'll minus with respect to the theoretical. So Q theoretical minus Q actual by Q theoretical into 100, because we need in the percentage. So we'll multiply with 100. Okay, again we simplify this equation, and Q theory by Q theory minus QA by Q theory. Can I write like that? So I know the ratio of the Q actual by Q theory is the coefficient of discharge, that is CD. So can I write this equation in this way? Okay, right. So this is the most important question. The slip will occur in the which type of pumps? That maybe occur in the reciprocating pump or centrifugal pump. We'll discuss in the upcoming session also. But what is definition? So definition is simply theoretical discharge and actual discharge difference. That is the case I want to convey here. Okay, please remember. So this type of question also be expected in the examination. The effective slip in the case of your centrifugal pump will lead what will reduce the flow rate, reduce the speed, reduce the energy, or increase the cavity. So answer is the reduce the energy. So means always there is a chance of loss of the water. So it will reduce the energy. Okay, in the centrifugal pump, not in the reciprocating pump. In the centrifugal pump, this question asked in the examinations. Okay. Now this slip are two types. Or was it I told you the slip is nothing but the difference between your between your theoretical discharge minus actual discharge. Suppose the theoretical discharge higher than the theoretical, that is one. Otherwise so based on this condition, the slip has been classified two types. One is your negative slip, another is a positive slip. So negative slip means the actual discharge is more than the theoretical discharge. Is it happen in real condition? The actual discharge is more than the theoretical. Suppose this is the cylinder. Okay, this cylinder is there. So this volume of this cylinder is, assume the 1000 liters. Okay, but you are getting the discharge from this cylinder is 1100 liters. Means you are getting excess of the 100 liters. So here you can say that actual discharge is higher, but theoretical discharge is lower. So this is called your negative slip. When will happen in this condition? Means the negative slip occur when the delivery pipe is too short. So this is the delivery pipe is the too short, and suction pipe is longer. Okay, in this condition, the actual discharge higher and theoretical discharge is lower. So this ratio always in this negative slip is more than the unity. So this is the most important question. So in the negative slip condition, what is the coefficient discharge? That is the lesser than 1, more than 1, or equal to 1, or 0. So that is always more than the 1. Okay. Or when will negative slip occur? Option A, delivery pipe is short, delivery pipe is long, delivery pipe is neglected. All such type of questions may be asked. So that is the question here given. The negative slip occurred because of the suction pipe will larger as compared to the pressure in the delivery valve, or overlapping the two walls, overlapping the both walls. When the, so what does it mean overlapping? When this piston moves in this direction, both valve, the suction valve will open and delivery valve will also be open. Okay, the valve timing we call. So in this condition also, the theoretical discharge will lesser and actual discharge is more. Okay, the reverse is the your positive slip. When the actual discharge, okay, actual discharge delivered by the reciprocating pump is lesser than the theoretical discharge. Okay, here Q actual is lesser, means suppose the theoretical is 1000 liters, but actually is happen only 900. So this here the theoretical discharge will always more and actual discharge is lesser. So this is called your positive slip. Okay, this will happen due to the leakage. Okay, due to leakage or water again comes back to the in this condition, or due to other case or not compressing up due to the piston wear and tear, all the problems may be happen. So that's theoretical may be expected 1000, but you really expecting only 900 liters. So the 100 liters may be lost due to any leakage. So this is called your simply reciprocating pump concept of your slip, positive slip and negative slip. Next, separation. The cylinder pressure is lesser than the vapor pressure of your liquid, then dissolved gas is liberated from the liquid and cavitation takes place. As a result, a continuous flow does not exist. This is called your separation. Okay, so means the vapor pressure. When the cylinder, okay, in the cylinder water will enter, okay, and this water will evaporate. The water will evaporate and the forms the bubble, so that, okay, the gases will create in this condition. So as a result the cavitation will takes place. Okay, so in this condition the continuous flow will break. Okay, so that the flow will comes with some gap. Okay, so the flow will not continuously, so the flow will take some gap. That is called your separation. Okay, so this slip is depends on your number of your design, diameter of the piston, angle, geometry, all your conditions. Okay, so that is okay. So now which type of example comes in charge of the reciprocating pump is more than theoretical. Whether this statement is correct or wrong? Yes, this is correct. Okay, negative slip, the actual discharge is always more, okay, than the theoretical discharge, and the coefficient of discharge will more than unit x. This also be true. When the suction pipe is too short, delivery pipe is long, and the running at low speed and negative slip of the pump occur. No, this is the wrong. So here the concept is reversed. That suction pipe is short. No, the suction pipe is long, but delivery pipe is short. So only statement 1 and 2 are correct. So these are the some of the example asked in the your type. Okay, next work saved by the